In this lesson, we're going to take a look at graphing transformations of the cosine function. And you can see that in the top here, we're being asked to graph the function y equals -2 cos 1/2 x, or rather theta plus 45 minus 3. And because we're graphing the cosine function, let's just remind ourselves of what the cosine function actually looks like. So the cosine function normally starts up at 1, goes down to a minimum of -1, and then back up to 1 again. So that's the normal shape, and we know that it takes 360 degrees to finish one complete cycle, and that would make it at its minimum at 180 and then back at 0 for its maximum. So that's the original, or the basic, or the base cosine function. And what we have to graph is this complex looking thing at the top. But if we just take it a step at a time, we'll find that it really is pretty straightforward. So where do we begin? Well, the first thing I'm going to do is I'm going to look at this theta value inside here. And it's nice to see that the k value, the 1/2, which is the horizontal compression or stretch, it controls the, if you want to see the frequency of the wave, and it will affect the period. That has already been factored out of the theta plus 45. So I don't have to do any factoring of the inside here in order to get theta all by itself. It's already set up and ready to go, so that's nice that that step has already been done for us. I'm going to take a look at the tail end here, and the tail end has -3, and I know that this is the axis of the equation. That is sort of the middle of the equation. So what I'm going to do is I'm going to actually go to -3, so -1, -2, -3, right down here, and I'm going to put the axis on this graph right there at -3. Okay. Well, what next? Well, let's take a look at the front, and normally we'd say that this this -2 is the amplitude, but remember, amplitude is an absolute value. Amplitude does not have a sign. So this actually contains two parts. The negative is the reflection. Okay, so this is actually going to be sort of an upside down cosine function, or a reflected cosine function, and the 2 is the actual amplitude. Okay, so the amplitude, if we recall, is the distance away from the axis of the equation. So that means that we're going to have a 2 away from here, so 1, 2. So we're going to have a top maximum right there, and we're going to have a bottom, a -2 away, and we run out a little bit of graph paper, so that's okay. I'm just going to graph it right about there, and that will give me the channel, let's say right about, that looks pretty straight, right about there. So let's put some values on here. So our axis was at -3. That means that 2 above -3 is -1, and 2 below will be -5. Okay, so we've got our channel that this cosine curve is going to flow inside. What next? Well, let's take a look at the k value. The k value right here is 1/2, and that means we're only going to complete 1/2 of a cycle in 360 degrees. So the period of this would be equal to, the mathematical equation is 360 divided by 1/2, and that is 720. Okay, so because we're only going to get halfway through a complete cycle in 360, one full cycle is going to be 720 degrees. All right, the last little bit we'll look at is this phase shift here. And the phase shift, normally we would want to see theta minus a value, right? So this 45 is actually theta minus -45. That's how we got theta plus 45. So this is going to be a 45 degrees phase shift in the negative direction, or to the left. All right. So how do we graph this? Well, I'm going to need to put a scale on my axis of the equation. And in order to put the scale on, it's useful to take a look at both the period and the phase shift. So when I look at the period, I see that we have to fit in 720. So it looks like I'll have enough grid squares to get up to 720, as long as I don't make each square too small. The phase shift of 45 is going to happen, and it would be nice if we could line up 45 degrees right on one of the grid squares. Okay, so I'd have some choices here. I could make each square 15 degrees, and if I went up by 15, that would be 15, 30, 45, which means that 3 squares would make 45. Okay, well, that means that I'd need a whole lot of squares to get up to 720, and I wouldn't be able to fit 720 in there. So 1 square for 15 isn't going to work. However, if I had 1 square for 45 degrees, that would work pretty nice, because I'd be able to fit in the 720, and I'd also be able to fit in the phase shift of 45, and it would line up perfectly. So let's do that. I'm just going to say this is 45, so 45, 90, and then 45 again from 90 is 135, and then we'd have 180. So I'm just going to put the 180 in there, and 45, 90, 45, and there is 360. So it was 1, 2, 3, 4 ticks, gave me 180, and 1, 2, 3, 4 ticks gave me another 360. So 1, 2, 3, 4 ticks will give me 540, and 1, 2, 3, 4 ticks will give me 720. So there is the full 720 that I needed. There's enough space to show one complete period. And I'm going to go into the negatives here, and it was 1 tick is 45, so there's 1, 2, 3, 4, and that would be negative 180. Okay, well, let's get to graphing now. I'm going to put in a reference curve, and that is a curve that is not phase shifted. So I'm not going to move it left or right yet. All I'm going to do on the reference curve is I'm going to put in a curve that has the reflection in the axis. It has the amplitude, and it has the appropriate period. Okay, and then I'll shift it. So the cosine function normally starts up at the upper boundary of the channel, moves down to the negative, and then back up to the top. Because this is reflected, mine is going to start on the bottom of the channel. So I'm going to start it there at the bottom, and let's use a color that I think you'd be able to see a whole lot better. Why don't we pick this color right here, dark blue. There we go. Okay, so if the period is 720, that means that this upside down cosine function, or the inverted cosine function, will go from this point, and then down at 720, it will be back right there. Halfway through, it will be, instead of a minimum, it will be a maximum. So that will be at 360, which is right there. And notice that I'm working on the red upper and bottom of the channel. Well, let's put in the zeros. Well, the zeros would be halfway between those 2 points, so right there, and halfway between those 2 points, right there. So there is, if I just connect these together, there is a curve right there that has a period of 720. It has an amplitude of 2. It has been reflected, and it has an axis at y equals -3. Okay, so the only thing that hasn't been applied here is this phase shift to the left of 45. So by making a reference curve first, I can take these 5 points and just shift them to the left 45, and then I've got my appropriate curve. So we're going to do that. I'm going to take this point here that used to be at 0, and it's going to move to the left 45, which was 1 square. So I'm going to put it right there. Okay? This curve, or this point here, is going to go 1 to the left there. This point, 1 to the left here. This point, 1 to the left. And finally, this point, 1 to the left right there. And if I join these together with a nice smooth curve, you'll see that this goes down here, up to this maximum, down here to this, and then it would go up like that. So you can see that it has been shifted slightly to the left by 45 degrees. Okay, so that green curve is the final answer. If you were doing this on a test or something, I would suggest that once you get your final curve, use a highlighter or something and just highlight that curve. Remember, these types of questions might ask you for 1 complete cycle or 2 complete cycles. Make sure that you pay attention to the grid and the period, because if you have to show 2 complete cycles, then in this case 45 would not have been a good choice for the ticks. We would probably have to knock it down to something like 90. Okay. The other thing is, if it asks you to show 1 complete cycle starting at 0, well, then put in your final answer, and then make sure that you start at 0, and then you end at 720. And that would be your complete cycle. And you would just erase this little bit before and erase this little bit after 720, and that will show you 1 complete cycle. Okay, so that's how you could take something that looks fairly complicated, a cosine function, and you can graph a function that shows all the different transformations you could apply.